Have you ever wondered what lurks in the icy depths of our planet's polar seas? We often imagine these places as barren, frozen wastelands, but the reality is far stranger and more spectacular. Beneath the ice, in the frigid, dark waters, live some of the largest and most bizarre creatures on Earth. This is the world of polar gigantism, a mind-bending phenomenon where the extreme cold doesn't just slow things down, it supercharges them. Today, we diving deep into this alien world to uncover why creatures in the Arctic and Antarctic grow to monstrous sizes. Forget what you think you know about the poles. We're about to meet real-life sea monsters. Let's start with the undisputed heavyweight champion of the deep, the colossal squid. Living in the freezing waters around Antarctica, this isn't just a big squid. It's the largest invertebrate on the planet. Imagine a creature as heavy as a small car, with eyes the size of dinner plates, the largest eyes in the entire animal kingdom. They're armed with rotating hooks on their tentacles, making them fearsome predators of the Southern Ocean. While we've only encountered a few specimens, they tell a story of a creature perfectly adapted to its extreme environment, hunting in darkness thousands of feet below the surface. But the giants don't stop there. Picture a spider. Now, picture it with a leg span of over 2 feet. That's the giant sea spider for you. These aren't true spiders, but an ancient group of marine arthropods. In most parts of the world, they're tiny, barely noticeable. But in the polar seas, they become impossibly large and gangly, slowly striding across the seafloor like something out of a science fiction movie. They are so thin and their bodies so small that some of their organs, like parts of their digestive and reproductive systems, are actually located inside their legs. Talk about making efficient use of space. And what about starfish? The Antarctic starfish, Lebidiaster annulatus, is another perfect example. This isn't your typical 5-armed sea star. It's a sprawling, tangled web of up to 50 arms, resembling a creature from another planet as it crawls along the seabed, snaring krill and other small animals with its sticky, feathery limbs. It's a literal starburst of life in a place you'd least expect it. So, what's the secret behind this supersizing? Why do the poles breed giants? The answer lies in the unique chemistry of cold water. The first key ingredient is oxygen. Cold water can hold much more dissolved oxygen than warm water. For cold-blooded animals like invertebrates, whose metabolisms are directly tied to the temperature of their surroundings, this is a game-changer. It's like having a constant supply of high-octane fuel. This abundance of oxygen allows their bodies to grow much larger without their respiratory systems failing. In warmer waters, a giant sea spider simply wouldn't be able to get enough oxygen to support its large body. But in the oxygen-rich polar seas, the sky, or rather, the seabed is the limit. The second factor is metabolism. The extreme cold slows down the metabolic rates of these creatures dramatically. They grow very, very slowly, but they also live for a very long time. This slow and steady approach means they have a much longer growth period compared to their relatives in warmer waters. They don't burn out. They just keep growing year after year, decade after decade, until they reach these incredible sizes. Think of it as a life lived in slow motion, where size is the ultimate reward for patience. This combination of high oxygen supply and low metabolic demand creates the perfect storm for gigantism. Now, you might be thinking, doesn't it work the other way for some animals? And you'd be right. This phenomenon primarily applies to cold-blooded marine invertebrates. When we look at warm-blooded animals like penguins, seals, and polar bears, a different rule often applies, known as Bergmann's rule. This rule states that within a species, populations in colder climates tend to have larger bodies than those in warmer climates. Why? It's all about heat conservation. A larger body has a smaller surface area to volume ratio, meaning it loses heat more slowly. For a warm-blooded animal trying to stay warm in a freezing environment, being big is a huge advantage. It's why the emperor penguin in Antarctica is much larger than the Galapagos penguin living near the equator, and why the polar bear is the largest land carnivore. Their size is a thermal adaptation to survive the cold, whereas for the invertebrates, it's a metabolic consequence of the cold. But the polar story has another twist. It's not all giants. Scientists have also observed a phenomenon called polar dwarfism, particularly in certain groups like sea snails and clams. Some species in the Antarctic are actually smaller than their temperate or tropical relatives. The reasons for this are still being debated. It could be due to the limited availability of food during the long, dark polar winters, or the difficulty of extracting calcium from the water to build shells in such cold, Acidic conditions. This highlights just how complex these ecosystems are. The poles aren't governed by a single simple rule. Instead, they are a mosaic of extreme adaptations where some animals grow huge and others shrink. It's a delicate balance of physics, chemistry, and biology, fine-tuned over millions of years. Unfortunately, this unique and fragile world is now under threat. Climate change is warming our oceans, and the polar regions are warming faster than anywhere else on Earth. As the water temperature rises, its oxygen content will decrease. This could be catastrophic for the polar giants. Their entire existence is built on a foundation of cold, oxygen-rich water. As the oxygen levels drop, these giants may struggle to breathe. Their slow metabolisms, once an advantage, could become a liability, making it difficult for them to adapt to rapidly changing conditions. The giant sea spiders, the colossal squid, and the sprawling starfish could be some of the first victims of a warming world. We risk losing these incredible examples of life's ingenuity before we've even fully understood them. The study of polar gigantism isn't just about marveling at massive creatures. It's a window into how life can thrive in the most extreme conditions imaginable. It teaches us about the fundamental laws of biology and the intricate connections that sustain ecosystems. But it also serves as a stark warning. The fate of these mysterious giants is directly linked to our actions. Protecting the poles means protecting some of the most wondrous and weird life forms on our planet. So next time you think of the Arctic or Antarctic, don't just picture ice and snow. Picture a hidden world of giants, a testament to the power of adaptation, living slowly and growing large in the freezing deep. It's a world worth exploring, understanding, and most importantly, protecting. Thanks for joining us on this deep dive into the world of polar gigantism. If you found this as fascinating as I did, make sure to hit that like button and subscribe for more adventures into the weird and wonderful corners of our planet. Let us know in the comments which polar giant you find the most incredible. See you in the next video.